For this tutorial, we're going to take what we've learned previously on linear functions and use that knowledge to help us create and graph them. So let's start off with example 3. So here, they want us to graph a line that goes through the points 0, 0, and 2, 6. So let's draw our points first. So we have 0, 0, and then 2, 6. It's about right there. Now since we have 2 points, we could define a line. So if you have a ruler or another type of straight edge, you could just line up those points, and then from there draw the linear function. So that's how we would draw a function on the graph, or at least draw a linear function when given 2 points. Now let's try another example. So here, they want us to graph a line that crosses the x-axis at x equals -5 and the y-axis at y equals 2. So for this, it's actually referring to intercepts. So if you remember, intercepts is where a function crosses a particular axis. Now for example, the line will cross the x-axis at x equals -5. So we could go over to -5, and that's going to be where our linear function hits the horizontal axis. Now similarly, it's going to hit the y-axis at y equals 2. So that would be right here. So now we've drawn our 2 intercepts. And kind of like with the previous example, we now have 2 points that could define our line. So now we just need to get our straight edge and line it up with those 2 points that we found, and then draw our function. So now, using intercepts, we were able to create or graph this linear function. Now let's look at one more example. So here with example 5, they want us to graph the line that goes through the point 0, 1, but also has a slope of 2. So let's first graph our point. So we have x equals 0 when y equals 1. So that's where that would be. Now we have a slope of 2. Now if you remember, with slope, it represents how y is changing at the same time of when x is changing. So for us, they're saying that's 2. Now we could think of this as being 2 over 1, because 2 divided by 1 is still 2. But this gives us more of a description on how our slope is behaving. So our y is changing by positive 2, while x is changing by a value of positive 1. So to draw our line with this slope, we know that y will go up 2, while x will go over to the right 1, representing our positive 2 change in y and our positive 1 change in x. And we could just keep using these points in the slope to continually draw the line. So up 2 over 1, up 2 over 1, and so forth. Or we could also draw it in the reverse direction as well. So do the exact opposite. -2, -1, -2, -1. But again, we only need 2 points to actually draw a line. So we could line up our straight edge and then draw the line. So that's how you would graph a linear function if you're given only 1 point and its slope. Now with standard form, the x and y variables, or our input and output variables, are on one side, and a, b, and c are just constant values. An example of what this would look like is shown with example 6. So here we have 2x minus 3y equals 12. Now if we were to graph a function written in this form, the easiest way would be to find its intercepts. Now if you remember, with intercepts, that is where one of the variables is going to be 0. Now for example, if x were 0, we'd be finding the vertical intercept. So if we plug 0 in for x, we're left to just solve for y. Now 2 times 0 is just 0, so that's gone. So we're just left with the negative 3y equals 12. Well, when we divide the negative 3 to both sides, we're left with y equals a negative 4. So here we have our y-intercept, or where the function crosses the y-axis. Now we can do the same thing to find our x-intercept. Now for x-intercepts, y is 0. So we would have 2x minus 3 times 0 equals 12. Now 3 times 0 is just 0. So we're left with 2x equals 12. So when we divide by 2 to both sides, we get x equals 6. So we know that this particular function will cross the x-axis at x equals 6. Now with these two intercepts, we could graph the function, because these will show us the 2 points we could use to define the line. Another form is the point-slope form. Now with this one, it specifies a specific point along the line as well as the slope. Now in the formula, the point is defined by x1, y1, and the slope is whatever the value is for m. So m is going to equal the slope. Now let's take a look at an example of what a linear function would look like in this form. So let's take a look at example 7. So here, if we were given this function and wanted to graph it, we could find the point and a slope. So first of all, the point is going to be the x1 and y1 from the formula. Well, for the x1, we find it by the x minus x1. Well, here we have an x plus 5. Now what this tells us is that our x value is negative, because when you minus a negative value, it becomes a positive. So our x value for the point is negative 5. Now to find the y value, we see it as y minus the y1. Well, for us, we see y minus 4. So 4 must be our y1. So there's our point. And the slope is just going to be whatever this m is. Well, for us, that would be 3. So we can conclude that the slope for this particular function is 3. Now we would have enough information to graph the function if we needed to. Now let's take a look at one more form, and that would be the slope-intercept form. For this one, it isolates the output variable. So here we have y equals mx plus b. Now again, m is going to represent the slope, but b is actually going to be the y-intercept for this particular linear function. Now let's take a look at an example of what a linear function would look like in this form. So here with example 8, we have y equals negative 2/5 x plus 4. Now our slope is going to be whatever is in this m spot. So for us, the slope is going to be negative 2/5. And b is our y-intercept. Now since b is 4 for us, that means our y-intercept is 4. And we could write that as an actual point. So with y-intercepts, x is 0, and then it crosses at y equals 4. So now with this, we have a point and a slope that we could use to graph a linear function if we needed to. Now let's learn how to write equations for linear functions when given certain pieces of information. So let's first look at example 9. So here, they want us to write an equation in point-slope form for a line that goes through the point -2, -3 with a slope of 2. Now, if you remember, point-slope form is y minus y1 equals the slope times x minus x1. Well, for us, we have a point and we have a slope, and we could literally just substitute those in to this formula here. So we could have y minus whatever our y1 is equals our slope times x minus whatever our x1 is. So let's start with the y1. So we have y minus y1. Well, our y1 is -3. So we'll put a -3 in here for y1. Equals our slope, which is 2, times x minus x1. So now we just need to put our x1 in here. So since our x is -2, we'll put a -2 in there for our x1. So now let's clean this up a little bit. So we have y minus a -3. Well, minus a negative is a double negative. So that'll make it positive 3. So we have y plus 3 equals 2 times, we have x minus a -2, so a double negative again. So that changes it to be an x plus 2. So now we've written an equation for this particular linear function in point-slope form. Now let's take a look at one more example. So for this one, we need to write an equation in standard form for a line that goes through the points -3, 6 and 3, 2. Now standard form is the form where we have ax plus by equals c. Now there's not necessarily an easy way to write an equation in this form. Probably the best way to do it is to first write it in a different form. So let's put it in point-slope form first, which in that case we're going to need to find the slope. So let's find the slope by doing the slope formula. So y2 minus y1 over x2 minus x1. So let's just say this is our second point. So our y2 is 2 minus 6, and then divided by our x2, which is 3, minus our x1, which is a -3. So here, when we simplify, we have 2 minus 6, which is a -4, and then 3 minus a -3, it's a double negative, so it's actually 3 plus 3, which makes it 6. Now if we reduce this, it ends up being a -2/3. Or in other words, we have a slope of -2/3. Now to write this in the point-slope form, we need to do y minus a y value equals our slope, which is negative 2/3, times x minus an x value. Now we have 2 points here, and we only need one of them to write it in this form. So let's just choose one. Let's do 3, 2. So 2 would be our y value, and 3 would be our x value. So now we're going to want to simplify it to where we get x and y on the same side. So let's do that. So probably the easiest way to do that is we need to distribute this first. So we have a negative 2/3 x when we do this times this, and then do a negative 2/3 times a negative 3. Well, a negative times a negative is a positive, and when we do 2/3 times 3, we get 2. And then we still have the y minus 2 over here. Now, in order to get x and y both on the same side, let's move this over here with the y. So we'll add 2/3 x. It cancels on this side. But we need to do the same thing over here to the other side. So that leaves us with a 2/3 x plus y minus 2 equals a positive 2. So now we just need to get this constant term out of here. So we want the rest of the constant terms by itself. So we just need to add the 2 and then do the same thing to the other side. So that leaves us with a 2/3 x plus y equals 4. Now that would be the linear function in standard form. And that about wraps it up.